Hello everyone. Today we are going to discuss another method of finding out the square root of a number. So today's method is finding the square root through prime factorization. Now you all are well familiar with this word called prime factorization. So let us see how with the help of prime factors we can find out the square root of a number. So here it is given, consider the prime factorization of the following numbers and their squares. So here is a table you can see. These are the prime factors of a number and these are the prime factors of its square. You can see the 6 is a number and its square is 36. If you see carefully the pattern, can you find out something from here? First thing is that these are all prime factors, 2, 3, 5, here also 2, 3 and 5. No other factors are used here, so these are definitely prime factors. But if you see carefully, you will notice one pattern. On the left hand side, one pattern is being followed. On the right hand side, a different pattern is being followed. Can you find it out? Okay, so you can see in this point, in the prime factorization of a square number, we can see that the prime factors occurs twice the number of times it occurs in the prime factorization of the number itself. Yes, this is the difference, or you can say that this is the pattern that is being followed. You can see here in the prime factorization of the number, that is say 6, it is 2 into 3. But when it comes to the prime factorization of its square, that is 36, what do you see? It becomes double. 2 was here, it was only once, here it became twice. 3 also, it was once here and it became twice. Similarly here also in case of 8, 2 was repeated 3 times. Here it becomes how many times? 1, 2, 3, 4, 5, 6. So whenever we do the prime factorization of a number and then we do the prime factorization of its square, we will see that in its square prime factorization, the number of the times the factor occurs becomes double. Clear? Whatever factors were there in the case of the prime factorization of the number, that same factors would be there in the prime factorization of its square as well, but it will occur twice. It will occur double. Clear? Now let us see how to find out the square root using this prime factorization method. For this, we will go on with the examples. So first example is very clear. We have to find out the square root of 6400. So how to do that? Simple. We will follow the prime factorization. We will find out the prime factors. What are the prime factors of this? We can do it in this way, in this method. We'll divide it, go on dividing until it comes to a single digit or a simpler form, you can say. But remember, all the factors, whatever we will do or will be using here, all those will be prime factors. So then we will tabulate all this in this way. So I can see 2 into 2, 2 into 2, 2 into 2, and we will just put a line below it. Why? We'll underline because we need 2, 2 here. Why 2, 2? Because whenever we have to find out the square root, we have to always group them in 2's. This is one of the easiest technique of finding out the square root. Always we'll group them in 2's. The same factors, of course. We will not group 5 and 2. We will group 5 and 5 only. 2 and 2 only. So after grouping them, from one group we'll take only 1. So here 2 into 2 will take only 2. Here another 2. Here 2. Here 2. And here 5. So from the group we will take only 1. So one group will denote only one factor actually. So then we will then multiply this. After multiplying whatever number we get, that will be the square root of this required number. Clear? Simple method. Now what if we have to check? Here definitely this is a perfect square number, so we had no problem. What if we have to check that whether, or what if we are given such a number which is not a perfect square number? Then in that case, how can we find out the square root? Definitely we can't. But we have to first check that whether the number that is given to us is a perfect square number or not. For that, let us see, if the question has been asked, is 90 a perfect square? Then what we have to do is that we have to first find out the prime factors of it. So these are the prime factors. Now if you see carefully, only this prime factor 3 has been repeated once, but the other prime factors 2 and 5 are not repeated. So we can't do the pairing here. I have said it grouping, but the perfect word for it is called pairing. So this 3 is paired. Pairing means 2. So here 2 is not paired and 5 is also not paired. So definitely, even if one of the factor is not paired, then and there we can say that it is not a perfect square. Clear? So 90 is definitely not a perfect square. So we can't find out the square root of this number. The number has to be a perfect square. Only then we can find out the square root of that number. Clear? Now moving on to the next example. Say we are given, is this a perfect square? So again, same method, we have to find out, is it or is it not? And if not, already is mentioned, if not, that means it is definitely not. So even by reading the question, you can find out the answer by yourself. So while the questions are given to you, always I prefer you to read it carefully, because the answer is hidden within the question. So here it is already given, is this a perfect square? If not, that means definitely 2352 is not a perfect square. We already got some hint. So then what we have to do is that, if not, find the smallest multiple of this, which is a perfect square. We have to now find out the smallest multiple. Then we have to find out the square root. We have to make it a perfect square, that means, and then we have to find out the square root of that number. So how to do that? First of all, we have to see, we have to find out, not see actually, we have to find out the prime factors of this. And then we'll do the starting the pairing. So you can see here, only 3 is not paired, all the factors are paired. So definitely this is not a perfect square. We have already got the idea. Now what we'll do is that, if 3 gets a pair, then the number becomes perfect square. Yes, we need only one more 3. Then our job is done. So we'll give them one more 3. How will we give them? If you have to give them one more 3, we have to multiply this number also with 3. We are giving this 3 a 3, and we are not giving 2352 a 3. That would be unfair, right? So we will give him also 1 3 and to him also 1 3. Clear? So if we give, or giving means we will multiply. So if we will multiply 2352 with 3, we get this. So this number now is a perfect square. Thus, the smallest multiple of 2352 is this, which is the perfect square. Clear? And the perfect square of the square root of this number is 84. Why it is the smallest multiple? Because multiple we already know. I don't need to repeat that, I suppose. So, which is the smallest multiple? If we multiply 2352 with 2, it is not. If we multiply 2352 with 1, no. So if we multiply 2352 with 3, then that number is a perfect square. So definitely this number, whichever number we got, that is 7056, is the smallest multiple of the number which is given to us, 2352, which will be a perfect square. And then finding out the square root is very simple by using the earlier method, or you can say by just now we have done an example on that. So you can find out the square root by that process. Now moving on to the next question. Find the smallest number by which 9408 must be divided so that the quotient is a perfect square. Here also same thing. First of all, I have to find the prime factors. We have skipped to the earlier, means the next slide. So, okay, again there is some problem, I guess. Okay, so sorry for that inconvenience. So you can see here, whenever we have to find out, first of all, we have to find out what is that. We have to find out the prime factors of this number, and then we'll start pairing as usual. After pairing, we will see that this 3 is left behind. Now, here asked that what must be divided so that the quotient is a perfect square. So this 3 is our obstacle. If we remove this 3, our job is done here. Now in the earlier case we have multiplied it, but here we will do the opposite. We will divide it, because it is already mentioned here that what must be divided. So we will divide by 3. Now same case, if we will divide by 3, this will turn to 1. So it is, you can say, nullified, or it is gone. So here also, if we divide this with 3, we have to divide this also with 3. So we'll divide this 9408 with 3. We got 3136. And if we'll divide 3 with 3, it is gone. Now our job is done. So this number 3136 is the perfect square. Clear? So what is the smallest number which after dividing we got this perfect square? Obviously it is 3. And then what we have to find? We have to find the square root of this number, quotient. So quotient will be this. So I have to find out the square root of this number. So that's very simple. I hope you understood this. Now moving on to the last example. This example, you can see, find out the smallest square number which is divisible by each of the numbers 6, 9 and 15. Okay, now you might be thinking you have to find out 3 different numbers. No, you have to find only single number. So what we'll do here is that first of all we'll take the LCM of 6, 9 and 15. So what we got after taking out the LCM? We got 90. And you can also see that whatever factors that we got after taking the LCM, all of them are prime factors. So we can also say that this LCM is nothing but it is the prime factorization of 6, 9 and 15. Or you can say it is the prime factorization of 90, you can say, because LCM is 90. So you can say this is the prime factorization. These are the prime factors of 90. 2 into 3 into. And then what we'll do is that we will start pairing. Here also again 3 is paired, but 2 and 5 is not paired. Now we have to find out what we have to do in order to make this number a square number. So obviously we have to supply them another 2 and another 5. So here if you supply them another 2 and another 5, that will turn out to be 2 into 5, that is 10, means extra 10 we have to put up here, so that the number becomes a square number. So if we'll put here 2 and 5 extra, then it will be 10. So it is very simple. If you're putting 10 here, you have to put it here also on the left hand side. So 90 into 10 will be 900. So this is the smallest square number that would be divisible by 6, 9 and 15. You can try it out by yourself. 900 will be divisible by 6 also, 900 will be divisible by 9 also, and 900 will be divisible by 15 also. So this is the smallest square number. And also it is a square number. 900 is a square number, perfect square number, because its square root can be found out. So I hope you'll have understood today's class. We have also discussed the examples, and these all examples are the examples of prime factorization method. So you can again practice it out in your notebook, check for yourself that whether these are the square numbers or not, so you'll have a better understanding. So that's it then for today. Thank you and have a nice day.